Hello, welcome to the part 3 video on differential amplifiers. In the last video, we looked at how the differential amplifier or the output of the differential amplifier, which is a differential output, would reject a differential input. So in this video, we are going to go into a further details on the differential amplifiers and how they are constructed. So assuming that previously, if we wanted the transistor Q2 not to only help us in noise cancellation but also help in boosting the signal, and we connected Q2 also to get part of the signal in an attempt to amplify it, then we realize that at the output, as the differential output, we were going to get zero output because the differential pair were going to reject that common input. So how do we get a differential signal at the input, and what exactly do we mean by a differential signal? So this is what qualifies to be a differential signal. Assuming I have a microphone signal with V0 being 10 millivolts, then it will look like this. Okay, so we saw in the previous video that if the same signal is given to the other transistor, then from this equation right here, the two were going to cancel out. But what if we made the actual signal we needed negative? Then subtracting Vy from Vx would mean we would have the gain times the input, that's the output, plus the ripples from the noise as Vx minus the negative output signal. So this negative simply means the output signal has been shifted by a phase degree of 180 plus Vr, and in that case this will be cancelled out by that, and we are going to have the output signal being 2 AVR. That's the gain times the input voltage. So this is the output voltage, twice what we would have got from a single Vx. Okay, so the key point is, how do we get that phase shift, and what actually qualifies to be a differential signal that can be fed into the differential input without being rejected. So first, one of the signals should be 180 degrees phase shifted from the other. So then the other signal going to Q2 should look like this. Okay, so first of all, we should pay attention to two things. Number one, there should be a 180 degree phase shift. Okay, and number two, the average values of these signals should be the same. Okay, so in this particular scenario here, we know that the average value is 0. The sinusoid has an average value of 0. But what if, as we are already used to, we know if the microphone is connected directly to the transistor, we wouldn't have enough voltage to bias the transistor. So we want to create a bias voltage which is going to have the signal coming from the microphone being superimposed on top of it. So that means that the voltage coming out from the microphone, our plus 10 millivolts, estimated pure sinusoidal coming from the microphone, if superimposed with a bias voltage at a DC level of 700 millivolts, then the signal is now going to look like 10 millivolt sinusoid omega t, and the frequency can be maybe somewhere 1 kilohertz. By this time, there's going to be a 700 millivolt DC offset. So for the two signals to be considered sinusoid. Okay, also in this case, now the average of this signal would no longer be 0, because the average of this signal is now going to be 700 millivolt, and this signal will look something like this. If we have 0 and up here is 700 millivolt, this is how we are going to have the signal. Okay, so the next signal coming in, if it qualifies to be a differential pair or differential signal, then it should also have 180 degrees phase shift, and 2, the average value should be the same. So if that signal is here, then the two of them do not qualify to form a differential signal to the input. So to qualify to be a differential signal to the input, then this is going to Q1, and what is going to Q2 should look like this. And the two conditions are satisfied. So we call this average value, in this case 700 millivolts, we would call it the common mode voltage, CM. So these are some terminologies we'll be coming across a lot. We just need to familiarize ourselves with them. Alright, so this is what we call the common mode voltage. And if the two signals V1 and V2 are differential signals, then they should have the same common mode voltage, and they should also be 180 degrees phase shifted. So the next question would be, how could we generate a signal like this if my microphone is just giving me a single-ended voltage with respect to ground, and a transformer can do that pretty well. So once the microphone is connected to a transformer, then a center tap is placed as a center tap transformer. So one signal from this side to the ground, being the center tap, will give me, so if this winding is double that here, then one signal at the center tap from the top to the center tap would give me exactly what is coming out from here. And from this side to the center tap would give me the required 180 degrees phase shift. So I can just write that as minus V naught sine omega t. So then in that case we connect this to that side and we connect this to this side. Okay, another thing that we should pay attention to is how error will be rejected in this case, or noise. Assuming there's any form of noise here, then this noise is going to be common to the differential input, and the output is going to reject all commons, so the noise would be rejected. So that is one way we can look at it. So in the next video we will look at how to build a proper differential pair. Until then, see you later. Don't forget to like and subscribe to the channel.